Today's learning target is for you to solve problems using ratios and proportions. I'm going to leave it to you to turn the learning target into the essential question for today's notes. If A and B are two quantities that are measured in the same unit, then the ratio of A to B is A over B. Please remember that ratios must be in simplest form, and they also have to have the same units. So you can't have inches over feet in a ratio. Be careful about that. A proportion is an equation that equates two ratios. All right, here's some vocabulary dealing with proportions that you probably haven't seen before. In the proportion, A over B equals C over D. A and D are the extremes. B and C are the means. So we have extremes and means. In order to remember which one is which, I look alphabetical order, extreme and mean. E is first, so the top first number is where the extremes start, and it's on the diagonal. We have some properties, theorems, that deal with proportions. The first one actually has a name, the reciprocal property. If two ratios are equal, then their reciprocals are also equal. So if A over B equals C over D, then B over A equals D over C. Now we have some unnamed theorems. The first one says when you have a proportion, you can switch the means, and the answer is still the same. The second one says when in a proportion, you can add the denominator to the numerator and still keep the proportion equal. So notice here I added B, which was the denominator of the left side of the proportion. So on the right side I have to add D, the denominator on the right side of the proportion. Neither one of these properties has a name, so if you're using them in a theorem, you have to write it out the way it's written here. So let's do some practice. If you remember from elementary school, when you have a proportion, you cross multiply. Now be careful when there's adding and subtracting in your proportion. Put parentheses around that adding and subtracting before you cross multiply, because this is 3 times the quantity of x plus 4. That equals 8 times x. Then you have to distribute. Then subtract the 3x, and x will equal 12 fifths. No decimals. Let's look at the next one. Again, before I start, I'm going to put parentheses around my subtraction, and then I'll look at my cross multiplying. This is going to be x times x minus 5 equaling 8 times negative 3. So that's x squared minus 5x equals negative 24. Okay, x squared means I have a quadratic. Quadratics have 2 possible solutions. So I have to make the quadratic equal 0 before I can solve this. All right, positive 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6, and they both have to be negative in order to factor this. And as I look at it, none of them will add up to a negative 5. So this one cannot be factored. If you can't factor the quadratic, then you have to use the quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac, divide all by 2a. that's going to be negative 5 is 5, plus or minus the square root of negative 5 squared minus 4 times 1 times positive 24. Make sure that radical goes over the entire expression, divided by 2 times 1. Now, I want my calculator. 25 minus 4 times 1 times 24 is a negative 71. So at this point, you have to remember from Algebra 1, what are the solutions when the radical is radicand, the number under the radical is negative. And in this case, there is no real solutions. Alrighty, we've got a word problem. Let's see. A scale model of a car. You like my fancy car? Scale model of a car is 10 inches long and 5 inches wide. The actual car is 60 inches tall. What is the length? Such an incredible artist. Alright, so when you set up your proportion, you've got options. I tend to go corresponding sides. So 5 over 60 will equal 10 over x. 5x equals 600. So x equals 120 inches. Make sure you include the units. Alright guys, you have a couple of questions to do and a summary.